All right. Good morning, mathematicians. Or good afternoon if you're in period 2. Okay. Please, before you start this video, please make sure that you have completed lesson 2.3, all about slicing pyramids and prisms, learning about cross sections. Okay. So if you did not complete that, please complete that before you do this, before you start 3.1. Okay. All right, let's go ahead and dive right in. So 3.1 is called going around in circles. We're talking specifically about the circumference of circles, and that's actually our first vocabulary word today. The focus question is, what is the relationship between the diameter or the radius of a circle and its circumference? So by the end of this lesson, we should be able to answer this question by stating exactly how the diameter is related to the circumference, or how the radius is related to the circumference, and vice versa. Okay, so you might remember the word circumference being the length around a circle. Okay, there's another way of thinking about it. We call with other shapes the length around other shapes. You guys might know that as the perimeter of shapes, right? So you could think of the circumference as just the perimeter of a circle. So this would be the perimeter of a circle. And what we're going to do for our drawing here is try your best to draw a circle. Okay. And the circumference is, I'm going to label that by writing circumference around the circle, if that makes sense. So the circumference goes along the outside. Circumference goes along the outside of the circle, all the way around, just like the perimeter. Okay, so that's our circumference. Now the diameter is, it's a part of our circle. This is the line that starts on one side of the circle, passes through the center, passes through the center, then goes to the other side. Then to other side is what I'll say. So we have our circle here, and right there is the center of our circle. Now your diameter is going to start from one side of the circle, go through the center, and then touch the other side of the circle. So it'll look something like this. I'm going to go ahead and label this diameter. So it's cutting all the way through the circle. And remember that there's an infinite number of diameters that a circle can have. So this is only one example. Another diameter could be something like this, or something like this. Oh, I don't know what happened there. Something like that. Right? So long as it starts on one side, goes through the center of the circle, and then touches the other side of the circle, then we can call all of those lines diameters. All right, radius is the diameter's little brother, right? So this line the line that starts, right, it starts on one side. It starts just like our diameter. So the line that starts on one side of the circle and stops in the center. So we'll draw our circle again. Draw your center of your circle, and then the radius is going to start on one side of the circle and travel to the center. So this right here is my radius. Okay, and there's a special relationship between the diameter and the radius of a circle. Most of you are probably saying, oh yes, the radius is just half of the diameter. If you said that, you are exactly right. So the radius, I'm going to write an equation for it. The radius is 1/2 of the diameter. And I'm sure you guys could write another one for the diameter. Right? How is the diameter related to the radius? Well, you're just doing the opposite, right? So instead of dividing by 2 or multiplying by 1/2, this time you're multiplying by 2. So diameter equals 2 times your radius. So you can always go back and forth from radius to diameter or diameter to radius, whatever you need to help you answer the question. Okay, so I think we have enough information to actually start our lesson here. And it's a pretty short lesson. Look, it's only 1 page. Woo! All right. So what we're going to do, if I were actually there today, I would have had you guys with measuring tapes, and we would have measured circular objects like your hydro flasks or water bottles or clocks. I don't have any round tables in my room, but unfortunately, I'm not there. So what we're going to do is we're going to take a look at some of these, at some round objects, okay? Give me a second. Here's one. We're going to take a look at this pi, as in P-I-E. Okay. And so in our table here, we're going to write pi. And this table is going to help us figure out that relationship between the circumference and the diameter. Okay. So this pi, let's say it has a radius of, a diameter of 5 inches. So it's a pretty small pi. Okay, so we're going to say that the diameter is 5 inches. Okay, and you also know that the circumference of said pi is, give me 1 second here. We'll say that is, undo, there we go. The circumference of this pi is about 16 inches. All right, so we're going to go ahead and fill that in our circumference. Now, in this last column here, you're going to write a ratio, circumference over diameter, okay? So I'm working over in this column here. Remember, you're writing circumference over diameter, 16 over 5. Okay, and I want you to go ahead and type that into your calculator, 16 divided by 5, and you're going to write down what you get. So I have 3.2. Okay, so we're gonna keep that. We're gonna look at some more circular objects here, and we're gonna try and see if we can find a pattern relating the circumference and the diameter here. Okay, let's take a look. I have 2 more photos for you guys. I have a pizza. And of course, this is a vegan pepperoni pizza. I knew you guys were thinking that. Okay, so I'm going to tell you that, actually, I don't think that's going to show up very well. The diameter of this pizza, I'm going to say, is 7 inches. And the circumference of this pizza, that's cool, it autocorrected to a weird polygon, but I want a circle, please. There we are. And I'll say that the circumference of this circle is 22 inches. Okay, so in your second column, or in your second row, go ahead and write pizza. And then I have one more shape for you guys. This is going to be our classic clock face, so right here. Okay, so this is the face of a clock in whatever classroom, and you notice that the diameter of this clock is 12 inches. And the circumference, it did a polygon again. Come on. There we go. And then the circumference of this clock is going to be 38 inches. Okay. So what I want you guys to do is I want you to go ahead, fill in the rest of this chart, please. So pause the video here, fill in the rest of the chart. Remember, this last step, I'm going to box it in red. Write your ratio, divide the numerator by the denominator, and we're going to record the decimal that we get. So pause the video, go ahead. All right, so this shouldn't have taken you very long. So I want to talk about this last column, though, the circumference divided by the diameter. When we get 22 and we divide it by 7, we get, actually I'm not going to write equals here because we get a non-terminating decimal, meaning it goes on forever. I'm just going to round it to the nearest hundredth, 3.142, so I'm going to, hey, look at that, 3.14. Bells already might be going off in your brain, but let's go ahead and look at the clock. The diameter we said was 12 inches, and then the circumference is 38. And so when we write our ratio, 38 over 12, let's see what that is. And that's approximately 3.17. Okay, so taking a look at our results from question 1, this table, we're going to look for a pattern relating the circumference and the diameter. Specifically, we are looking at the ratio of the circumference to the diameter. Take a second to think. What do you notice? Is there something that always happens when we divide the circumference by the diameter? Think about that for a second. Maybe ask a neighbor. Say, hey, are you on this part of the video? Do you notice anything? Okay, so take a moment, pause the video, ask someone around you. All right, hopefully you pause the video. So notice how every time we divide the circumference by the diameter, the decimal that we get is always a little bit above 3. You see that, right? So the first one was 3.2, the next one was 3.14, and then the next one was 3.17. You might have noticed that when we divide, where can I write this? Okay, hopefully you guys didn't copy down, or hopefully you guys didn't draw these because I'm going to get rid of them so I can write stuff down. Okay, so when we divide the circumference by the diameter, we get a number that's just over 3. Now, think about this for a second. These numbers over here that I'm boxing right now, 3.2, 3.14, 3.17, they are all really close to a very special number in math. There's even a holiday for it. Take a second, think about it. Please tell me you thought of pi. Yes, the circumference divided by your diameter is always going to give you pi. Isn't that cool? Yeah, try it with any circular object that you guys find at home today. Measure its diameter, measure the circumference, divide the circumference by the diameter. You're going to get awfully close to pi. All right, so we're going to take this thing that we just came up with, the circumference divided by the diameter to equal pi. We need to answer this question. Can you find the circumference of a circle if you know its diameter? So we're looking for the circumference and we want to know what is it equal to. Again, use this information over here. You know that circumference divided by diameter equals pi. See if you can create a fact family statement to help you write an equation for circumference. Okay, so take a minute, pause the video, try and answer this question on your own. All right, hopefully pause the video. We're talking about circumference. We want to know what it equals. So I'm gonna rewrite this over here. So we have the circumference, we're dividing it by the diameter, and we get by pi, or we get it equal to pi, or as close as we can get to pi, okay? So I'm rearranging this formula right here to help me solve for the variable c, in this case the circumference. So I need to get c isolated, I need to get c by itself. So I need to get rid of this d over here. So how I'm going to do that is I'm actually going to multiply my left side by d. And what I do to one side of my equation, as you guys might remember from last year, you have to do to the right side or to the other side of your equation. So when I multiply c divided by d, these d's are going to cancel out. So I'm left with c. And now I have pi times d. Now if I were to write the words out here, this is my circumference. That is equal to pi, right? This is pi times the diameter. And there you have a nifty formula for finding the circumference of a circle. Wonderful. So we're going to write that down. Circumference equals pi times your diameter. And we kind of answered the if so how part of this question over here. Right, we used fact families to rearrange this circumference divided by diameter equals pi to create the circumference equals pi times the diameter. Okay, the next question is a very similar question. Can you find the diameter if you know its circumference? So what we are trying to find is the diameter, and I want to know what it equals in terms of circumference and pi. What can I do? So use this very first thing, the circumference divided by the diameter equals pi. Actually, you can also use this one over here. You can use circumference equals pi times diameter to help you figure out this final equation, or this final formula. So take a minute, pause the video please, and try and answer it on your own. If you get stuck, maybe ask a neighbor. All right, go ahead and pause. All right, hopefully you pause the video. So I think it would be beneficial to use the circumference equals pi times diameter to help me solve 2.2. So c equals pi times d. Now remember, what am I solving for? Well, I'm looking for the diameter. Diameter is right here, and it's being multiplied by something. So I need to isolate it. I need to get it by itself. So in order to get rid of this pi here, right, I'm going to divide both sides of my equation by pi, right, and now I get c, the circumference, divided by pi is equal to the diameter, because these would then cancel each other out. So let's write that in words. So to find the diameter, if you know the circumference, you take the circumference and you divide it by pi. And there we go. So we have, well, technically, I guess we have three different formulas here. I do want to highlight one more thing about circumference, right? This time I'm working in purple. Okay. I want you guys to think about, how do I find circumference if I'm given a radius instead of a diameter? Think about that for a second. Pause the video, maybe talk to a neighbor, okay? But try and answer this question, please. So go ahead and pause the video. All right, hopefully you paused and thought on your own. So remember, we're multiplying pi times the diameter. We need, and I'm looking for a formula that I can use to, when I'm given a radius instead of a diameter. So what I'm going to do is I'm going to look back at my vocabulary, specifically these two relationships, right? I can always rewrite my diameter as a radius, so long as I multiply that radius by 2. So going back to this question that I'm giving you guys, it's not actually written on here, but I'm forcing you to think about it. We know that pi is definitely involved in finding the circumference, but now I need to rewrite this diameter as a radius, right? So hopefully you got something like this. Pi times 2 times your radius. And this right here, this section right here, this 2 times your radius, that is the same thing as your diameter. So we have 2 ways of finding circumference, if given a diameter or if given a radius. All right, you guys, nice investigation work here. Please let me know if you have any questions, and I will see you in the next video.